All right. Well, welcome to school here today, and we are going to be taking a look at 5.5, 5.6 dividing polynomials. As you recall, in a textbook that we're using, Math Makes Sense 9 by Pearson, they do multiplying and dividing in both 5.5 and 5.6. We've split it up into just multiplying. We did that last lesson. And then dividing we're going to talk about today. Okay, so maybe somebody could grab that door. I hear some voices out in the hallway. Can you grab that door, Michael? Thanks. All right, so dividing polynomials. Very much the same as multiplying. It's connected. Obviously the rules are a little bit different. We do things sort of opposite, actually, but they're connected, right? Just like multiplying two numbers would be connected to a division. So, there's my pen. All right, so for example, multiplying and dividing are connected in that if you have 4 times 5 equals 20, that's connected by division in that we could say that 20 divided by, and I'll use a little line there like that, divided by 5 equals what? Shout it out. 4. Equals 4, right. So if we go 4 times 5 is 20, we know that 20 divided by 5 is 4, and also 20 divided by 4 is 5. So multiplication and division are connected. So let's talk about how we divide polynomials. We'll talk about how we just work with the expressions that were given there and the division, just like on the front page. And then we'll finish up by talking about how to work that out with algebra tiles. All right. So when you think about dividing, okay, if you have a monomial divided by another monomial, or in this case, really this should be a constant, because this is the example for a constant. So I'm just going to write constant here, because this is what the constant example is. Okay, I'm going to just scratch that out, because we do have a monomial down here. So when you divide a monomial by a constant, it's easy in the sense that you just divide the numbers to the number by the number. So just like we multiplied number times number, we divide number divided by number, okay? So if we focus on 4 divided by 2, right, that gives us 2. 4 divided by 2 is 2. Now the x squared has nothing to divide it by, so we don't really change the x squared. As long as it's on top in what's called the numerator is on top, so I don't know if you know that word, but numerator is on top, and the denominator is on the bottom. So you'll hear me say those words, and that's what I mean. The number or the term or the terms or the expression, whatever, on top is numerator, bottom is denominator. So if this variable part is in the numerator, we just simply rewrite it just like that, because it's not being changed or divided by really anything at all. So another similarity to multiplication is that like terms, okay, variables, the same variables can be divided. They don't have to be exactly alike. So addition and subtraction, they have to be like in that same variable with the exact same exponent, then you can combine them. In multiplication and division, they just have to be the same variable, and then you can work with different exponents. All right, so that's pretty easy right there. 4x squareds divided by 2. Think about this as, and this is algebra tile method a little bit here. So if we have 4x squareds, like 4 large squares, and if I literally divide that by 2, divide it into 2 groups, okay, in each group I have 2x squareds. And that's visually how you can view that. And we'll talk more about algebra tiles a little bit later, okay? But you're literally dividing it into however many groups you have on the bottom there if it's a constant. Okay, any questions about that? Pretty easy, right? Okay, let's go to the next one. What if you're dividing a monomial by another monomial that has a variable? Okay, so if that's the case, then we have to remember our rules. When we multiply and divide the same variables, we just focus on the exponents. So let me remind you that in multiplying, what did we do with the exponents? If we have x times x squared, what's the answer there? X what? X cubed. Yeah, it's x cubed, and that's because we added 1 plus 2, right? So in dividing is the opposite of multiplying. So what's your guess? What do you think we should do with the exponents of like variables when we divide? What do you think? subtract. Exactly. That's exactly what we do. It's pretty easy. So I'm going to have still my numbers divided by numbers. So let me just highlight that for you again. So 4 divided by 2, those are the numbers divided by numbers. So I'm going to have, I'll just zoom back out here so you can see it all together. So I'm going to have 4 divided by 2 is 2. And x squared divided by x to the power of 1 is going to be x to the power of, and I'll just show it here, 2 minus 1, okay? Which is equal to 2x, right? 2 minus 1 would be 1, all right? Another way that I like to show this, because the essence of dividing is working with factors, and in order to simplify or divide, that's what you're actually doing, is you're actually eliminating common factors. So watch this. I like to show this also like this. I split it up into, well, I'm going to split that 4 up actually too, into prime factors, is what they're called. So factors that have no other factors other than 1 in itself. So 4 is really, if you break that down as much as you can, it's 2 times 2, and then you have times x times x. That's the kind of fully expanded version of that monomial on top. The fully expanded version of the monomial on the bottom is simply 2 times x. So another way to view this is when you're dividing, you can actually separate like factors. So there's a 2 as a factor on top and a 2 as a factor on the bottom. And then there's an x as a factor on top and an x as a factor on the bottom. And 2x divided by 2x is just 1. And so what am I left with? If I eliminate those, or if I divide those out, I'm left with 2 times x in the numerator, and that's my answer over here. Okay? So when we have monomials, you can also view those as, you can break them down into prime factors, and then you can divide out all the common factors on the top and bottom, simplify those, and then just write whatever's left over. Okay? But we'll kind of keep it simple with just the rules here to begin with. Number divided by number, variable divided by variable. Okay? All right, so what happens if we have an example like this? Okay, so 4x squared minus 8x divided by 2. So this is a constant again, and so we want to think about, if I had all these as algebra tiles, I just need to try and split them up into 2 identical groups, and then whatever's in each group is my answer. So we'll talk about that again a little bit later. But what do we do just algebraically with numbers? Well, what we can do is we can split these up into 2 separate fractions. Okay? Now, in order to explain this a little bit better, I want to back up a little bit, and I'm going to show you a couple other things. So think about this example. If you have 2/3 and you add 1/3, okay? So if we're adding fractions that have a common denominator, I can go ahead and combine those 2 fractions into 1, right? And what I do is I keep the bottom number, that's the denominator, I keep the same denominator, and then I go ahead and I add 2 plus 1. So that becomes 3/3, right? So 2/3 plus 1/3 is 3/3, which equals 1. But what I want to focus on is just this part right here, where we see that if I have a fraction, I can actually split it up into 2 identical denominator fractions. So I can split anything up. And here I split the 3 into 2 and 1, and I kept this common denominator. So going backwards like this is the key to doing this part. So I'll show on the right side here what I mean. So I'm going to split 4x squared minus 8x all over 2. I'm going to split that into 2 identical fractions with a common denominator. And I'm going to show it like this. 4x squared over 2 minus 8x over 2. So I'm going to take that binomial on the top, and I'm going to split it into 2 fractions with a common denominator. So that's this as one fraction, and then this as another fraction. Okay? And you can do that with however many terms are on top. If you've got 7 terms on top and 1 term on the bottom, you can write 7 fractions that are added or subtracted with the same common denominator. So if this is the case over here, then I just simply follow all my rules, and I'm left with, that equals, try and fit it in over here, 4 divided by 2 is 2. X squared divided by, well, there's nothing to reduce it by down here, so we'll just leave that 2x squared. And then minus 8 divided by 2 is 4x. All right, so that should be your answer there, 2x squared minus 4x. Okay, I'll pause here for a second. Is there any questions about any of these examples so far? No, everybody's getting it? Easy, you could do this stuff on your own here now? Okay. All right, well, let's take a look at this last example for this section. So 4x squared minus 8x over 2x. Well, again, what we can do is we can split this into two fractions that are subtracted. So I'm going to split this into 4x squared over 2x minus 8x over 2x. And that way we'll be able to do simpler calculations here. So 4x squared divided by 2x, well, 4 divided by 2 is 2. X squared divided by x, we said, was x to the power of 2 minus 1, or just x to the 1. So we'll just write that as 2x, just like we did up here, right? And then minus 8x divided by 2. Well, 8 divided by 2 is 4. What's x divided by x? What's x divided by x? So if we follow the rules, right? If we follow the rules, it would be x to the power of 1 minus 1. That would be x to the power of 0. What's x to the power of 0? It's 1, actually. Anything to the power of 0 is 1. Unless it's 0 to the power of 0. That's the only exception. But anything to the power of 0 is 1. And if you think about it this way, if you have x divided by itself, so anything divided by itself is 1, right? You're going to have 100 million divided by 100 million. That's 1, right? You can have a purple dinosaur divided by a purple dinosaur is 1. Anything divided by itself is 1. Not sure how you'd actually divide purple dinosaurs, but if it were the case, the answer would be 1. Okay, let's go back up here. So 2x minus 4 would be the answer there. Any questions? All right, let's do some more examples. And I hope you are writing all this down. You have these blank notes for a reason, so that I'm helping you do your notes here. So if you don't have at least some of this down, I mean, I have all my little examples and my little markings. Make sure you're writing down the answers there anyway, so you can look back to that. But I'm going to move on now to the examples here. So what we're going to do is we're going to split each one of these division problems here. We're going to split each one into separate division problems, just like we did, and then we'll answer those. So here the first one's done for you all the way through. So let's take a quick look at that. If I have this trinomial divided by a monomial there, I'm going to split that up into 3 separate divisions to do there. And 12m squared divided by 3 is 4m squared. Plus, I'll keep this sign here, plus 6m divided by 3 is 2m, and minus goes there. And 9 divided by 3 is 3. So that is your answer. Okay, so for this one, again, they've split it up for you. Should be pretty straightforward now. You know how to do this. And now let's go ahead and finish this last one. So what's negative 3 divided by negative 3? That's a positive 1, right? So you can write 1 there. Let's write 1 there, positive 1. Y squared divided by, well, there's no other y's in the bottom, so we'll just leave y squared. So if you notice 1y squared, we normally don't write the 1, so you can erase that. It would be proper. So that's just y squared. Now, 15 divided by negative 3. So what you can consider is, and I would suggest this, consider this plus sign here and this minus sign together and do that division appropriately. So we have a positive 15 divided by a negative 3. So positive divided by negative, what's the answer going to be? Is it going to be positive or negative? Yeah, it's going to be negative, so we'll write that as a minus. Very good. And then 15 divided by 3, if we just take the 15 and divide it into 3 groups, how many are in each group? 5. Excellent. Now, it's just a monomial, or it's just a constant on the bottom, so we're not really changing any of the variables. So I'll just go ahead and write an x, y there as well. So x, y stays. And finally, negative 21 divided by negative 3 would be plus 7x squared. And then that's your answer there. Any questions? All right. What I'm going to get you to do is I'm going to get you to do C on your own. If you haven't started that already, please do C on your own. Show all the steps like I have. Show all those steps like I have, okay? So while we're learning this, I want you to show all the steps so that you can make sure that your brain gets it seated deep in there what we're doing. Okay, so I'll do it in the background while you go ahead and take a minute to do that on your own. All right, so here should be your answer for C. You should split each one of those into 3 separate little divisions. So this big trinomial on top divided by 3 can be split into 3 separate fractions there. So I have 12m squared over 3 plus 6m over 3 plus 3 over 3. Each one of those simplify to 4m squared and then plus 2m and then plus 1. All right, any questions about that, C? How many of you got that before I showed you the answer? You get that? Awesome. Okay. All right, let's move on. Let's take a look at algebra tiles. Okay, so how are we going to do this using algebra tiles? Again, the goal is for you not to rely on algebra tiles for too long, but when you're first learning about this stuff, it sometimes is very helpful to envision algebra tiles. Envision something that's a little more concrete. And so drawing pictures and sketching the algebra tiles might really, really help you. So please feel free to do that. Let me explain how algebra tiles work for division. As mentioned before, if you're dividing by a constant, you're simply taking the sketch of the algebra tiles that you would see on top, and the goal is to divide them into however many groups that you see on the bottom there. So literally, in this case, we're going to take negative 4x squared, and I think I did this exact example here just really quickly for you. It was positive 4x squared, so yeah, very close. But we're going to take negative 4x squared, so that's these dark large squares, and we're going to split them into 2 groups. And if we can split them into 2 equal groups, so you can't just like cut them roughly in half and say, oh, here's half and here's half, but they aren't the same. They have to be the same. So it has to be really in half into 2 equal groups. They always have to be equal groups. And then whatever is in the one group, that's the answer to the division. Okay? So for example, if you think about a regular division problem, like if you and your 4 friends, there's 5 of you, if you have $10 and you're going to 7-Eleven, okay, how many dollars do you each have if you have $10? Well, it's 10 divided by 5, so the answer to that division would be the number of dollars that each of you have, right? 10 divided by 5 is 2. So it's the same thing. You have a group and you split it evenly into however many groups, and then the answer is what's in each group. All right, so it's pretty straightforward. This one here, you draw all the algebra tiles just as you see them. So the algebra tiles that are drawn are the ones on the top. Okay, that's important. Don't draw like a 2 squares on the bottom. Don't draw the 2 squares, little squares. You're just drawing the stuff on top, and then you have to try and split it into 2 equal groups. And of course, in this case, if you split it into 2 equal groups, you have negative 2x squared plus 4x, and I think that was very similar to the question we did. Okay, except we didn't have negative here, but very similar. Okay. So I think there should be, is there some blanks you have to fill in here? No, I don't know, split into 2 equal groups. Okay, so for this question here, we have negative 2x's, x squareds, I guess. So that's in each group, so that's your answer. So you're going to fill that in. Do you have that in your notes? Do you have that little blank? All right, so you split this one into 2 equal groups, and you should have negative 2x squared plus 4x, and that's your answer. Okay, so that's dividing by a constant. Okay, that's dividing by a constant. That's the easiest type of division. Now, if you divide by a monomial, okay, it gets a little bit different, but it still is connected to multiplication. So let's remember what we did last week, or I guess a while ago before the break. So what we did in multiplication is you had like a big square, right? And you put the one term on the side. So that was the side like this one, right? So negative 2x. And then if you were multiplying, you put the other thing you were multiplying on the top part. And then you filled in sort of the dimensions of both sides, and you filled in the middle part. So I won't go over that again, but division is connected to multiplication. And so what we do is we put this part right here, the negative 4x squared, we put that as the middle part. So you draw negative 4x squared, and then dividing it by this monomial down here, this is what we put on one side. And so we kind of treat it like a multiplication statement, but instead of finding what's missing in the middle, we find what's missing on the side. Okay? And so if you could do that, then that's going to be your answer. All right. So for this one, what would I fill in over here? Well, it has to be this long, right? Because that's the length of each of the solutions in the middle there. And so we're going to fill that in as, looks like x tiles. And we have a negative times a what would give us a negative? Well, a negative times a positive should give us a negative. So it looks like my answer is positive 2x. So positive 2x should be the answer. And that's exactly what we get. If we do this algebraically, negative 4 divided by negative 2 is positive 2. X squared divided by x is x to the power of 1. So there you go. So you just fill in this missing side here of the multiplication sort of picture for the tiles. Okay? That's how we would do that. Let's do another example. Okay, and this one got cut off on my notes. Is it okay on yours? It's okay on your notes? Yeah, going to the screen here didn't translate very well, so I filled them in really quickly. But if you have negative 4x squared plus 8x, that's again what you put here in this middle part. Okay, you draw all those there, you put them all in there, and then you do have to kind of arrange them too so that they're symmetrical in either a square or a rectangle, right? And so the way you arrange them is important too. So the one dimension is negative 2x. So you have to have, this has to be negative 2x. So when you arrange the middle pieces, you have to arrange them such that the one side is the same as whatever is on the bottom here. So if we have a negative 2x here, then once this is set up just like this, then you have to try and find this missing top part. All right? And I guess the answer would be here. It looks like this is going to be an x because that's the length of this. This is going to be an x. Now is it positive or negative? Well, negative times positive would give us negative, okay? And then this one here looks like it's got to be just pretty small. So that's a small square, right? And how many? 1, 2, 3, and 4. And are these negative or positive up top here? Well, a negative times what would give us a negative? Or you could think about this. A positive, this is positive, divided by a negative would give us disappear. Okay. Wow. Computer, let's do this real quick. So this should be a what? Negative? Yeah, it should be negative here. Because again, a negative times a negative will give you a positive. So this is now a complete algebra tile multiplication statement that we learned last week. Okay, so that's now complete. So my answer is what I filled in. This is my answer. And it's going to be positive 2x minus 4. Okay, 2x minus 4. So any questions at all about that? Now this might seem like a little bit of work, a little bit extra work to do the tiles, and I get it. I am going to get you to practice using the tiles. Again, because it might really help you in the future to really solidify this. So Let's see here. Okay, for these questions here, I want you to write this. We're going to use we're going to do tiles for some of these, not for all of them. Let's do tiles for I, and let's do tiles X, Y. Well, let me see. Do I have one? These aren't really friendly. Some of these aren't really friendly for tiles. Let me just see. Oh, maybe we can't do tiles for too many of these, actually. All right. So we'll do tiles for these two. Okay? So we'll do tiles for these two, for I and L. And I will do some of these for you, and I'll get you to do the rest. So let me do some of these with you. Okay, find the following quotients. B to the power of 8 divided by B to the power of 4. There's no numbers involved other than just 1 and 1, so we don't have to worry about numbers. 1 really would be understood to be here, and there would be a 1 there too, so 1 divided by 1 is just 1, so you don't have to write anything. But B to the 8 divided by B to the 4, that's the same as B to the 8 minus 4, isn't it? Which equals B to the 4. Yeah, good job. Okay. I'm going to skip down to E because I think these are pretty easy. You guys will be able to get the B and C pretty easy. So let's skip down to E. So again, no numbers to really deal with there, just ones, so we won't worry about those. A, we're going to have 6 A's up top and 3 A's on the bottom. So 6 minus 3 leaves us with 3 A's on top there. If I have 8 B's multiplied together on top and 2 B's multiplied together on the bottom, how many do I have left on the top? I have 6 after I simplify. Okay. Okay. I will, let me see here. Yeah, let me do G with you. I'm going to show you that that factoring method of writing the factors out. So let me just show you what G would look like. Now, you don't have to do this for each one, but I do want to show you this because it is something that might help you. Just like tiles might help some people, this showing the factors might really help you. What are you guys in grade 9? You guys will have to work with factors and dividing using factors. You'll have to do this a lot in grade 10, so you may as well kind of get a little bit used to it here now. So I would set this up like this. So 6 would be 3 times 2. Whoops, I'm zoomed in too much here. 3 times 2. You see that? I have 3 A's multiplied together. So that's A times A times A. I have 4 B's multiplied together. B times B times B times B. Okay. So that is the monomial on top. That's split into prime factors. That's what that's called. It's broken down as much as it can be. On the bottom, 22. Okay, I can divide that by 2. Gives me 11. 11 is prime, so I can't divide 11 by anything other than 1 in itself. So I'm going to go 11 times 2. And then I'm going to go times A times A times A. And I'm going to go times B times B times B times B, because there's 4 B's on the bottom. Okay? All right, so we have something very curious here. I have 3 A's on top here multiplied together, and I have exactly the same thing on the bottom multiplied together. So guess what? This is A cubed divided by A cubed, which is just 1. So there's no more A's left. It's A to the 0, which is just 1. And I also have 4 B's multiplied together on top and 4 B's multiplied together on the bottom. So you can kind of see how those would divide off, and I just have 1 there too. The other thing is curious is that I have a 2 as a factor on top and bottom, and so those get divided out. They kind of just go away. 2 divided by 2 is just 1. And so what I'm left with is a 3 on the top and an 11 on the bottom, and guess what? That's my answer. 3 over 11, or 3 divided by 11, or 3 elevenths.
Can you do question N?
N?
Yeah.
I probably could do question N. Yeah, is that something you want me to do?
Yeah.
Really? Okay, let's take a look at N. First of all, any questions about G? Again, you do not have to write it out like this. In grade 10, you will. You will have to do lots of work like that, but just for now, just so you can see how that works. Okay, let me do I. I'll do I. Yeah, I'll start you off on I. with the tiles, just so we're all on the same page, and then you can finish it. And then I'll do n, okay? So tiles would look like this. Okay, so 10x minus 25. That's going to be a little bit of drawing, all right? But we got to put 10 x's and minus 25. I need to divide that evenly into 5 groups, okay? So I'm going to put the x's on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 x's. And then you got to put 25 squares on the bottom. So I'm going to spread my last 5 out like this. Now why would I do that? Because I can see what I have to do. I have to divide these into 5 equal groups. So if I put my line right here, and then another line right there, 2, 3, 4, and 5. Now I've got them split into 5 equal groups. So what's the answer to this division problem? Okay, I didn't put this is actually, the 25s are minus, so I am going to have to make these are all minus, so that's good. We got to do that too. So we'll fill all those in. And the answer then would be, 2x is in each one, and we have negative 5 is also in each group. So we've got 2x's minus 5. Yeah, so this minus, you gotta color those ones in as well. Right on. Okay, everybody see that? Everybody get that? Any questions there? All right, so I was asked about n, so I'll do n as well. Okay, so I would write this as 4g squared divided by negative g squared. Now, this is curious because you've got a minus up here and you've got a minus on the bottom. So let's do this. Let's do minus g to the 6 over here divided by negative g squared. You could do this as well. I don't want to confuse you, but you could write this as a plus and then put a minus on top and for this, and a minus on the bottom for this. So you could do it this way too. That's no problem, but again, I don't want to confuse you, so I'll just keep it like we've been doing it. So 4 divided by a negative 1 is really what this is. So my answer should be negative 4 g squared divided by g squared. Well, all the g's are gone. So it's going to be just negative 4. And now this one is going to be a negative 1 divided by a negative 1. So that's going to be plus. And it's going to be g to the power of 6 minus 2, or g to the power of 4. So you can write it just like that, or you can also write it as this, g to the 4 minus 4. So both are acceptable, no matter which order you write that. And so, yeah. All right, so what I'm going to let you guys do is I'm going to let you guys work for 5 or 10 minutes here on these questions in your note package, please. Finish up these ones. I will show you some more answers in a few minutes so that you can check your answers to see if you're doing this correctly, and then I'll give you your textbook questions. Okay? All right, you're dismissed. There's some selected answers. And textbook questions if you're in my class here.